In this video, I'm going to point out a few key terms that you should be familiar with if before we start working with electrical circuits. So the first term I want to cover is current. Current, if you're looking at an equation that's describing electrical circuits or in the Ohm's law equation, which I address in a later video, is usually denoted by the capital letter of I, and current is measured in the units of amperes or amps for short. In next term, voltage. Voltage in an equation is usually denoted by the capital letter V, and voltage is measured in the units of volts. And then resistance. Resistance in an equation describing electrical circuits is denoted by the capital letter of R and is measured in the units of ohms. And you can see I have the capital Greek letter of omega here, and omega is used to represent ohms as well. You usually you will see this in schematics a lot, but whenever you see this letter omega here, no, especially in electrical circuits, anything related to electrical circuits is used to denote resistance. So let me kind of give you, let me give you a graphic illustration here of how these three terms relate to each other and what do they mean um, as far as an electrical circuit. So let's say I have a hill here, it's a pretty steep hill, and at the top of this hill I have um, some boulders, of various sizes, big, medium, and small. Okay? And so based on the difference here, like this height, like the steepness of this hill, you know that these boulders are going to fall in this direction here. Okay? These boulders are going to be moving. Okay? So these boulders in this picture, these would be analogous to current in a circuit because current is moving throughout a circuit. All right. And so you see that it's moving from a very high point to a low point. If you wanted to, you could say, okay, this is, positive and, down here is negative. And so current is moving, always moves in this particular direction here. But just know that current is what's moving throughout the circuit, and it's much like boulders moving down a hill. Now, as these boulders move down the hill, let's say like nothing's impeding their progress, but what if I add, like some barriers here? So obviously it's going to restrict the flow. Probably these certain boulders won't make it, but you can see it's going to create some resistance here. Okay, so these obstacles here, as the boulders or the current in our case is moving, that would be represent the resistance in the circuit. All right, and then finally, you notice that at the top of the hill and then all the way at the bottom of the hill, there's a difference in height. Okay, so this difference in height is analogous to the difference in potential between 2 points in a circuit, and the difference in potential between 2 points in a circuit, that is your voltage. Okay? So the greater as far as in terms of the difference in potential here, you can tell by the steepness here, this current is going to want to move pretty fast. If I had a hill that was not as steep, that's going to change the current here, the amount of current. Now, in another video, in my video where I'm describing, we're covering Ohm's law, you'll see the relationship in terms of the calculation between the value between volts and current. If resistance remains the same as volts go up, so will current, and vice versa. As long as resistance remains the same, but if resistance starts changing, you can see once we go over Ohm's law, you'll see the relationship between these three. But I hope this kind of gives you a more concrete um, representation of what these three terms mean in terms of as far as electrical circuits go.